o'clock. So it's like an unglorious time of the day to listen to me talking about event-driven architecture. There's going to be a lot of drawings and diagrams because this is an architecture talk. So if I fall asleep on my own talk, can you please wake me up? Because I'm still a little bit woozy with my jet lag and all. I have to cross 3 different time zones. And yeah, so I'm a bit sleepy. I apologize already. But I'm going to try to wake you up a little bit. So today we're going to talk about event-driven architecture in Azure. And there are a couple of things that I want to focus on. This is a little bit of a fundamental session. So I want to talk about some of the basic concepts around event-driven architecture. And for example, I want to focus on the different nuances that we come across when we are designing event-driven applications, because there's a lot, it gets kind of confusing sometimes. I'm a developer and I get very confused with the different terminologies around event-driven. And then we're gonna look at the different Azure services that we can use to implement this in practical. And there's a little bit of demo in the end, but like I said, because this is an architecture session, so I have mostly drawings and diagrams, and we're gonna go through that together. And towards the end, let's look at the different pitfalls that we can encounter, some of the challenges that we need to be careful about when we're designing event-driven applications. This is my first time on NDC stage, and I arrived in Sydney like a week ago already. I'm totally having fun, so I hope you guys have fun with me a little bit, have a little bit of energy, even though this is such a heavy architecture talk. Just a little bit of introduction about myself. My name is Marilag Dimatulac Svennevig now, and I am a software architect, and I've been in this industry for far too long, like really long. I'm not going to reveal how long, but recently I am obsessed with building cloud-native apps and app modernization, and I've always been passionate about patterns, domain-driven design, because I also think that really good architecture is really important, especially in developer wellness. I'm also very passionate about developer wellness, developer happiness, because all of these things with burnout, we want to avoid that. And I believe that really good architecture is one of the best ways to avoid developer burnout. I'm also very active in tech communities. I'm a founder of a not-for-profit organization called ulap.org, and we try to get some of these underserved kids certified in cloud data and technology, like 19 years old getting certified. I don't pity them. And yeah, I'm an Azure MVP, and I'm also an entrepreneur. I have my own company, crazy enough to start my own company 6 years ago. It's a cloud-native company. We're based in Copenhagen and Manila. It's called The Wise. I always want to start my talk with the why. Why do I want to talk about event-driven architecture? Why am I interested with event-driven architecture? Because if you think about it, it's like I'm a fan of stories. I read a lot of stories, I write stories, I listen to stories. And if you think about it, software development is just automating the stories of our lives. But we're automating the kind of like not significant stories of our life, like going shopping, so that we have more time to live out the stories that we really enjoy, like creating art. We shouldn't automate that. But when we design software, based on the principle of domain-driven design, we want to design software that kind of easy to understand because it's so close and it's so related to our everyday lives, to our stories. And this is where the terminologies in event-driven design and the patterns in event-driven design really resonate with me, because it really represents our everyday life, our stories, the stories of our existence. As humans, we value events. We remember events, we celebrate events, we react to events. Every time something happens, a fact happens, we react to it. So we should also try to model our software, which is the automation of our stories, based on the same principles. But there's another reason why I'm very keen with event-driven architecture. It's because there's a fundamental issue with the way we are creating our software now. So we talk about stories, right? But the way we are creating our software application now, where we are trying to just overwrite what's on our record, the record of our facts, we have mutable databases. Whenever we try to overwrite the facts in our databases. That's a very typical software architecture pattern. It's like we're skewing our stories. It's like reading the records in the database. It's like reading a fairy tale where you say, once upon a time, the princess met a prince and they live happily ever after. It's like the rest of the facts are gone with the traditional way of our software development. And this is, again, where some patterns in an event-driven application can really help us straighten out the story for us to record every single fact that led us to the current state of our application. And so that's my why. I want to solve that story. Like, this is our plan, and we have a lot of stories, facts happening all the time. One of my favorite stories is the story of my kids, just to illustrate how we design software nowadays. So these are my kids. This is my son, Rain, and this is my daughter, Rayla. And they moved with me to Denmark about a couple of years ago, and they are enrolled in a school called Birkerol Gymnasium. It's with a U, it's hard to pronounce, Birkerol Gymnasium. It's like having a potato in your mouth. So they're enrolled there. And actually, this year, my son just graduated. Yay, I have a full adult son. But I know it's hard to believe. I can't believe it myself. But don't tell him that. Oh, this is live. He's watching. Anyways, so if I look in his school records, if I look in the school system, I'm going to pull out his record, his profile, and it's just going to say graduated. But before that happened, he was also applying or accepted or registered and enrolled. So, but I don't see that anymore. It's gone. We, well-meaning developers, have overridden it. How many times have we developed software like this? Maybe we have some audit log, but that doesn't give us the full picture, and the audit log is not really meant for us to replay the state of the system and look at it in different time zones. So we want to change that with a better pattern. So what is event-driven architecture? Essentially, in a nutshell, it's an architectural style that relies on events. Events are simple, a statement of facts, something that has already happened, and rely on that to have event processors that can execute logic asynchronously based on these events to be able to execute a workflow or problem domain. So for example, in the use case that I have shown you with the student enrollment, so maybe there are different steps in the student enrollment and there are different processors in the same workflow, but you need something to bind this decoupled asynchronous processors, and you can use events to be able to trigger some action. And event-driven architecture is not new. You can use it in different combination with other architectural styles, like, you can use it in monolith, but it really shines in distributed applications where you have decoupled processors, and how to make sure that they don't have a very strong dependency with each other, but they can still communicate with each other via events. So therefore, a lot of use cases with event-driven architecture. It's, like I said, it's quite common. It's not new. So for example, cloud is inherently, at least partly, event-driven, like especially with the side with the cloud-native event-driven auto-scaling. So if you're familiar with Kubernetes and Kada, like you can use events like as signals to trigger some logic to be able to scale your, your infrastructure. IoT solutions are also very much event-driven. So for example, if you have devices in this room, you just ingest a lot of different data about the current temperature, and you take all these signals to adjust the temperature in the room. So it's also event-driven. Gaming is also another use case, but enterprise apps. How many of you build event-driven enterprise apps? Oh, quite a lot. Good. So it is mixed, yeah. Some of you probably getting there or looking into it, and like also in my experience in enterprise application development, there are still a lot of teams and developers who want to implement event-driven, but only partially, and some are still very traditional and doesn't really use events at all. And I think one of the reasons why there's a kind of a blocker for implementing event-driven is it can easily get complex because of some of the nuances that we face. So I want to go through some of these nuances so that we can clarify some of the terminologies. And really, for the people who have experience or a lot of experience with event-driven application, feel free to contradict, to raise your hand and say, that's not right. Because this is the point where architects really, or developers really, started pushing their own agenda. So no, that's not right. So it could happen, and it always happens. But let's see. So one of the very basic things, commands versus events. Some people get confused, some people understand it right away, but the thing is they're both messages that's used to trigger some sort of action, but the meaning itself, the subtlety in the language is very different. So commands are, it expresses your intention for an action to execute. So somebody wants something to happen. That's a command. It's very active. I want you to do this. So in our use case for student enrollment, you can say, register the student. And that's a command. Whereas an event, also a message that gets passed around in the system that can also trigger another action, but you trigger the action because something has happened. So for example, in the whole student enrollment system, after you have completed the student registration, there's an event called student registered, and that can trickle down to the system and execute more logic. So there's a difference in the way we use the verbs. Another thing with the command, if we compare, so command can be, first of all, validated, where events are already valid. It already happened. It's already a fact. So command needs to first validate before it executes an action. So if it's invalid, you throw an error. But if it's valid, then you execute the action. And the action can still fail and succeed. So a failed action is an event that you can still capture. Whereas an action that succeeded, or like, for example, student registered or student registration failed, they're both events drawn out from the same command. So understanding this terminology can help us really model our workflow, our system, and then implement that in code. So let's look at simple example in code. So this is an example of a very simple command. So like I said, your naming convention is always to start with the verb that's in present tense, register student, and it's also just data. So you have some data that, that you require to be able to execute a command. And then somewhere along the way, you probably have a command handler that gets triggered to execute an action. And after that action has completed, like maybe you have executed some logic, business logic, you called your database, or you did some validation, you can publish the event once you have completed. So event is also just a data. It's just model. Just the event, the data in the event then notes what happened. So it explains what happened. So what are the attributes that were changed? So for example, when you register the student, after the student is registered, then you probably need which student ID and what program they were registered to. And in event-driven application, you would also have an event handler, the event processor. So once this is triggered, then you can do something. And this sample code I showed you is very simple, and it's still in process. You're still not crossing network boundaries. You're still not triggering any other components. But this is just a very basic code. All right. So I hope you guys understand commands and events, very important terminology. So how do we trigger this chain of commands and events and chain and commands inside our system? So now we start looking at requests. Async requests is sometimes related to event-driven, but depends on your implementation. It's probably not event-driven yet. But a lot of people refer to just simple asynchronous requests as event-driven. But let's see. So this is very familiar. This is a very simple way of designing our application. You have the request-response model. And here you have just two components crossing the network. You probably have a UI component, fires up the request to the endpoint processes it, and right away deliver the response. So a lot of our APIs are built like this, but we all know that this could cause some issues later down the line with scalability and latency and all that. So you might want to decouple your components using asynchronous requests. So this is one of the patterns that you can use for asynchronous requests. This is not the only one. So in this pattern, you have your UI. Let's say, again, in the student enrollment use case, you have your UI, you register the student, you call an endpoint, and immediately you get a reply that we're processing your request, and the endpoint will enqueue this so that it can be processed later on by its handler. So it's like temporal processing. So the queue in the middle takes care of, decoupling of the components, and as well as scaling or load balancing or load leveling, so to make sure that you have enough instances of the handler that can handle the load, or that you can throttle the load so that you don't kill your handlers or your API. And then you have a way to, of course, if you need to reply back to your UI component, there are several ways. In this particular pattern, you use a polling pattern, wherein, like from the handler, maybe you save the state along the way, update the database, but then you also provide an endpoint for the UI to call to check the status of the long-running process. Once that's completed, you also provide a resource endpoint where your client can also see the final state of the processing. So for the student registration, you will have two endpoints to look at where are we in the process of student registration, and at the end, give me the record for registered student. There are other patterns for this. You can also do request reply, where you don't poll, but then the handler also sends a message back to the UI about the status or what has happened. Who thinks this is event-driven? Yes, could be, but a little bit in my book, not so much, because we're still pushing or sending a command. We're still requesting something to happen. Nothing has been triggered because something else has happened. So there's just a little subtle difference, yeah? But of course, this can be the starting point for event-driven. An event-driven application is a mix, so it can start from a simple request and then propagate into events. So let's look at the patterns for event-driven design. There are different topologies that you can use when designing applications to be event-driven. And this is the first one, which is what you call the broker choreography pattern. This is where things are fun and cool, but then they can go wrong, and no one has a single responsibility for what's happening. That means all the participants in this event-driven workflow need to be responsible enough to know what to do when something goes wrong. So if I give you an example, let's say in the student enrollment workflow, first you need to register the student, and after that, you automatically enroll the students in different classes based on the program. So that's a different bounded context, the classes. Student takes care of the student records, whereas the class enrollment takes care of the class domain aggregate, like who are the students enrolled, what are the classes. And at the same time, at the end of class enrollment, you're going to find out, okay, what kinds of books do I want to issue to the students who are enrolled in this class? But that books component or bounded context is, it's a different team that's developing that, and at the same time, it's a different set of users. It's a bookstore. So they're all participants in the whole student enrollment workflow. In the choreography pattern, so you have the concept of the event producer, which is, again, like the handler that first executed the student registration. And once that's completed, it broadcasts that, OK, I'm done with my job. I have registered the student. It uses an event broker. That's the only responsibility of the event broker is to know who are all the subscribers for this particular event. So it just pushes out this notification so that they can execute their own logic, like, for example, the class enrollment and the books, issuing of books. But what happens if something goes wrong in the class domain? For example, they can't enroll the class. So technically, the student enrollment isn't completed. Well, if you don't design your application well using this pattern, then it's hard, right? It's hard to do error handling. It can easily go haywire. So there are also other patterns for this. You can emit another event that something went wrong, and then the other participants can receive that and do like a compensating transaction pattern where they try to roll back what they have done. And yeah, it will work, but then it can get very complicated towards, if your scenario gets a bit more complex. But the good thing about this is because you don't have a dependency on a single entity, because they're all kind of independent, then it's easily scalable, it's a bit more flexible. So that's a very common pattern. And the next one is what you would call a mediator pattern or a process manager. So in this case, you actually have like one entity there, one function that sort of organize all these events and commands and error handling to be able to complete the entire workflow to solve the problem. So do you have, relatives that kind of, if you have reunions, family reunions, you always have one person that just takes care of everyone, make sure that everyone are present and attend, but they get very stressed at the end of the reunion. So that's like my sister for me. She calls all my relatives and it's like, oh, are you coming or not coming? Oh, you're sick. Oh, you're doing this. So she gets very stressed, but things happen. It's so much easier. We don't have to worry about changing our plans because someone else is doing it. So that's the same with this particular pattern. So you would typically have, what you would call a mediator that would also produce the events and push the events into different channels. And then the participating components, let's say the class components and the books component, can also still receive this notification. And once they're done, they can reply back to the mediator, so the mediator can continue executing the workflow. So it is, I would say, much more organized and safe and easier for error handling. But then you start becoming dependent on one entity. That's the trade-off. So that means there's one entity that has to know it all, that has to scale better. So it's not as scalable as the ones where it's all independent, but certainly a little safer. So for example, I'll give you an example in Azure. You could use something called Azure Functions, Azure Durable Functions, that can orchestrate all these different activities and can fire up commands, receive messages, and then fire another events. And then maybe that particular durable function can also keep track of the events pushed out to some service bus, to other components, and then it receives the message back once it's completed. And in our student enrollment workflow, maybe this is a student enrollment workflow, maybe this is the best pattern. To be able to complete the student enrollment workflow, we will have a mediator. But when do we use the choreography pattern in combination? I would say that it would be nice to use it like after the entire end-to-end workflow is completed, you can fire up another event, like your integration event, so that you can announce to the greater system that the particular workflow is completed. So let's say it's not just student registered, class enrolled, books issued, but student enrollment completed, and maybe other parts of the system is interested in that particular event so that they can execute their actions again. So you can use it in combination. So single unit of business workflow of logic may be better with mediator, but then with the larger integration pattern, you can also use or combine it with the choreography pattern. Yeah. So those are the two. Now, there's something else with event-driven architecture. So if you're very familiar, you probably have come across event streaming and event sourcing. Where does this all play out? What's the difference? Is there a difference even? So, I mean, it depends on our use case, right? So we keep on extending the event-driven architecture pattern. When do we, who uses event streaming in their architecture? Cool. And how about event sourcing? How does that go? Let me know. Yeah. So what is event stream? So again, similar use case, but now we're thinking about other use cases. So the event stream is very, very good also with ingesting big data, large amount of data, particularly for analytics. So the scenario we had earlier, the messages that we're passing, the commands that we're passing are isolated to a single business workflow. And the simple pattern for choreography and mediator will suffice. But before the student has actually registered or classes are enrolled, there are like minute details that are actually happening every second and every minute before we even get to the point that the student is registered. For example, in the UI, you might have the student or the teacher must have clicked different buttons first. Maybe they invoked an error. Maybe they switched context and page and came back before, before everything was completed. So there are like these small data points that's still relevant in our story of student enrollment. You might want to catch because you might want to improve your service. You might want to do analytics on it. So this, ingestion of big amounts of data stream is very good for data for event streaming. And the concept is that instead of having an event broker, like in the previous pattern, you could have what you call an append-only log. So for example, your UI keeps on, pushing all these activities, user activities in an append-only log, and that log is designed to push out streams of data, and stream is just an unbounded data set. Unbounded meaning it's always growing, it's timeless, and then it's in order, it's immutable, and you can replay the data that's in the stream. And your stream processors consume this data. And maybe they only consume particular, events that are interesting to them. So for example, if you have a stream processor that wants to isolate all the events related to errors on the UI so that you can do some analytics to improve your UI, then you would only listen to, to those events. So you can listen to a particular topic. So maybe you have an event processor that's interested with the things, all the other things that the user is doing in the browser before they get to the point of registering. And then you can use that and then do some aggregation or transformation, or maybe you want to derive some data and refresh your read model that is more suitable for reporting or for other use cases. So you want to listen to the stream and process this stream. So it's slightly different from just announcing or notifying that a business process has been completed. But this one is really minute detail, and event stream is really good for that. You can implement it if you need it, if you have the capacity, if you understand your use case and the value from it, yes, but it's not necessary. That's the same with the concept of event source. Event source is also logging a series of events. But the difference is that the event source, when we use event streaming, we're talking about pushing data to other external processors. Whereas event storming is more internal. It's still in the same bounded context. Let's look at the bounded context of a student. Yeah, so it's just about the student registration. And event source just means that every single event that that happened in order to arrive to the current state of the student will be persisted in a persistence infrastructure, like a database. And it's going to stay there forever. Unlike in event streams, the streams actually don't have to stay forever. They can be retained. There's a retention period for your streams because, it's real time. It's real time. Your processors are just accumulating and processing all the time. It can go back in time. It can choose in which time window it wants to process, but at some point, those logs will be removed. Whereas in event source, everything that has happened to a particular entity, domain entity like the student, is persisted in a database, and what do you use it for? So that you can go through every single fact and arrive at the current state. So again, going back to the story that we're overriding our mutable records or databases, this is kind of like the answer for that. So instead of overriding, you just record every event that has transpired and use that and query that or replay that to be able to arrive at the current state at any given time. You can go back in a different time and you will see a different state of the entity or the aggregate. And at the same time, with the event source, the thing that you need to watch out for with event source is, of course, your log can really grow. So it depends on your use case. You have to watch out for that. But it's really also very good for debugging, for error handling, for looking at what happened. Again, it's not something that we have to apply all the time, depends on a use case. It can get complicated, but it's worth looking at. So what is the difference with an event source with a traditional log, for example? We can do audit logs, right? But like I said, the logs, if you do audit logging, so this is very good, event source is very good for audit logging, but if you do the traditional audit logging and not event source, it's only like we're logging just a subset of the information that we needed, not the whole state, not the whole transition of state. So for example, in the student registration, you might have something in your audit log, student status change, by who, at what date. And that's all you see in the log. Whereas in an event source, you have the full picture of the current state of the student at the time something has changed. All right? Who wants to implement event source now? No one? Me. Okay, there's one more thing in the list of nuances. Change data capture. So we have just been talking about data all the time. Data persisted in a log, data persisted as event source in an event store. All of this is just data persistence or manipulation of data. So what is the difference with our event logs, with our traditional database, with our batch files, et cetera? So change data capture is kind of a current feature of some of the modern databases nowadays. So what it means is that every time a document, if it's a document database, for example, or a record in an RDBMS has been created or changed, updated, or deleted, it fires an event that you can consume, that you can listen to as a component. So for example, let's say Azure Cosmos DB has the concept of change feed. So every time you manipulate the document, you can listen to the feed. You can fire up an Azure function that binds to the change feed and do some logic to it. And you can also use like a normal .NET Core application to use the change feed processor so that you can go through the feed and do some action. So yeah, certainly we can do this in an event-driven, in our event-driven landscape. But it's like the concept of something happening in the database and hooking up to it is also not new. We also have the concept of database triggers before, where we write some custom code because something has happened. And we also have transaction logs in the database, but they were never really designed for chaining commands and events before. Like the transaction log, the audit log is, again, meant for thinking what happened before, but it's not to execute a particular business or domain process. So what in my book, with the change data capture, for me, if I use it to execute business logic based on what happened to a document or to a database record, it doesn't feel right because it's so much related to the infrastructure and not to the business. When we walk around registering a student, we don't talk about, oh, did you update the database? Or maybe you do, but it's like it's not close to the real world. We're getting tied up. We're getting a dependency on our infrastructure layer because events are actually, on the application layer. It describes the flow of events in the business. But hooking up to a database doesn't feel right for me to be used to complete a business process. Maybe you can use the change data capture to manipulate your data. So for example, in Cosmos DB, you can hook up to this event if you want to maybe copy the data into a different container so you can change the partitioning strategy that is more optimized for a different type of read. So maybe you can use the change data capture to just transform your data in your database and then save it again in the same database. So it's a lot of more manipulation within the infrastructure layer and not the business. You can certainly use it together. You can certainly use change data capture in Cosmos DB if you have an event source there, and then push that into to your event stream, let's say to Kafka or to Azure Event Hub. It can work, and you just make sure that you know what you're doing and what are the trade-offs. So now, I guess I hope it's a little clearer, the terminologies and nuances. Let's take a look at the different services in Azure that we can use for particular use cases. So there are a lot. It's just, if you go there, it's like do event-driven architecture, then you're already bombarded with a lot of different options. So it's a matter of understanding, again, your stories and your use case, and then weighing on the trade-offs and seeing what works, right? And again, just a reminder that when you analyze trade-offs, architectural trade-offs, don't just focus on the technology. You also have to focus on your people, the ones who are going to implement this, their maturity level, the developers, the ops that's going to maintain this infrastructure, the cost of it. So it's not just like the technical features or architectural features of the services that you need to focus on. So what are the services? For the simple async request, the one we were talking about earlier, where you have a queue that could do load balancing or load leveling, you can start with the storage queue. It's a cheaper option. It has a very strong SLA. And the good thing with the Azure, very simple Azure storage queue is it actually has a larger maximum limit for the size of your queue because it's storage, yeah? So it's files. So it can accommodate up to 500 terabytes of worth of messages, which is a lot. So if you need to push large messages, you could start with this. But again, it's a queue, so it's pool style. And it can only guarantee at least once. That's another thing we need to remember. Like, at least once, it means that maybe it persists the message. So if the queue goes down, it persisted it somewhere, so it goes up again, that message is still there. But you cannot guarantee that you will only receive it once. You might receive it twice, or thrice, or I don't know, 100 times. And your processor, your event processor, needs to be able to handle that duplication. If you need a little bit more advanced messaging, yeah, with features like ordering or request, reply patterns, then Service Bus is probably your next choice. And it's also pool style, but be mindful of the limits on the amount of data that you can put. So if you're pushing large messages, you might end up exhausting the 80 gigabytes, but it can guarantee at least at most once. So that means it has some logic already to do, or algorithm already to do some deduplication. Supports dead lettering, so you can also subscribe to a dead letter and do your error handling after that. And it also supports the concept of sessions. So you can assign a consumer or event consumer, event processor to the same session, and every time you push messages within that same session, let's say, again, the student registration flow, there could be several messages related to the same student, which is the same session, then from there you can guarantee the order. If you don't have sessions and you have competing consumers, you cannot guarantee order in Service Bus. So have to remember that. And then it also supports, transactions, which is also really, really important. So if your consumer is, if your producer is pushing data within the same transaction, if one of those messages fail, it can roll back the rest of the events or the messages. So if you have that kind of need, then Service Bus is your choice. And then we go to like the more pub-sub pattern, like the one I showed you with a choreography pattern, with the broker pattern. And the next candidate would be the event grid. So event grid is really built for also push style notification. So versus like the two other queues are pool style. So that means your consumers need to be able to know how to connect to your messaging service. So it has that information, whereas if it's event grid, it's push style, then it's the event grid who knows or understands how to connect to the subscriber. There's a big difference. Like, for example, you can use event grid to also push data outside of your organization as long as you have access to that. Let's say in the student enrollment, maybe you need to connect to some webhook for the government system, and you have the authentication. You can do that in event grid. But that government system couldn't just listen to your internal Service Bus. So you have to think about that. And because event grid can do this, it also requires that the consumers or the subscribers have a public IP. So that might be an issue for you if you can't do that in your network. It's serverless. It's massively scalable. It can just push, I don't know, millions of notifications to a single consumer per second. So you have to make sure that your consumer can also accommodate that. Maybe put a service bus in front of it so that you can also do load leveling and load balancing. So for Event Stream, there are also several services in Azure that you can use. Event Hub and the very popular event streaming product which is Apache Kafka. And you can run Apache Kafka on your own if you have the capability, and you can do the entire operation of your Kafka clusters in your VMs or containers or in your Kubernetes clusters. But you can also use cloud-based Kafka, which is run by Confluence, and of course, you let them manage it, you pay them to do that. It's much easier for you. And then you have Event Hub. Event Hub is very similar to what Kafka can do when it comes to streaming, but it's, of course, Azure native. Supports HTTPS and AMQP style messaging. There's different tiers, and you can read all about the different limits in Event Hub. But the good thing about Event Hub is that it's like portable to Kafka. So if you have code that talks to Kafka because you have Kafka running somewhere else outside Azure, you don't have to change your code to be able to connect to the Event Hub, and then you take advantage of all the service level agreements from Azure for Event Hub. For event source, we don't really dictate what you can use to store your events. Of course, there are some persistence products that's built for events, but on the cloud, you can use pretty much any cloud database in Azure, like SQL or your storage or managed Postgres or Cosmos DB. All right, so I didn't talk about some of the integration services because it's a little bit too much to deal with, but I mentioned already that in the bigger picture, this is all integration points. So you have logic apps, Azure Durable Functions, Azure Functions, API management to do several things to be able to pull this all together, your workflow. Let's look a little bit on code. I have a very simple sample code just so we kind of have an understanding how this is going to look like in real. And if I replace all those funny diagrams I showed you earlier with actual Azure services, then you can see that we can put it all together. I'm not saying that this is the most optimized solution. I'm just using this so that we can illustrate the point that you can actually have service bus, managing the load for your requests, and then you can publish your events to an event grid. You can have event grid push that data into other service buses that your other components like classes and books are listening to. And then you can save your state or your events in Cosmos DB. All right. So this is a very simple implementation, just so we get an idea how this works. So in this code, or in this application, I have 3 different distinct applications, and the goal is that they don't talk to each other. They don't have reference to each other. They don't invoke each other's API directly, because otherwise, if you do that, you're essentially building, baby monoliths that's just inside a nursery and playing and making chaos. So I have 3 separate APIs, the students, the classes, and the books. And I just wanted to show how we create classes or model our commands and our events. So this is the command for when you want to register a student, and you will have a handler. And in this particular sample code, I'm also using a library. Are you familiar with the Mediator library? Yeah, so that library is a lightweight library for in-process messaging, and it can help you with all your command invocation and your event handler invocation without all the headaches of dependency injection. So it makes it very easy to invoke these commands handlers and event handlers based on the signature of your commands and events. So it looks through your assembly and does the magic. So I'm using Mediator here. You can use other libraries. I think there's Ian Cooper. He's also talking a lot about event-driven, and he's also showing code in Brighter. You can also check that out. So the whole idea is that you have the command, and then you have an event handler. Inside my event handler, I might do some logic. And then at the end of it, I'll publish the event called student register, and I would have two handlers for the event. One is writing to the event grid so I can do my publishing to an integration, and then I also have another handler for storing that particular event to my persistence. So the difference between a command and a command handler and an event handler is that command can only have one handler. So it will only invoke one handler, but if you look at this code with the mediator, so if you invoke publish, it will find all the handlers that implement that particular signature for your event, so it will execute it. So it's one-to-one versus one-to-many. So you can design your application like that. So I have that, and once that's done, once I call it, it will also automatically enroll the student in several classes by writing to event grid, and the event grid pushing to service bus, and then this class's API is listening to that service bus. Again, if you're using Azure Functions, you can easily do this by binding your functions, because that's inherently event-driven, binding your functions to service bus. But in this case, because this is a .NET Core Web API, I used what you call a hosted service, which is like a background service that gets started as soon as you start your application, and then it's just open. It will call the service bus all the time to get a batch of messages and data. So it's very simple code here to implement hosted service. So you have the method for start async, which will be invoked when you start the application, and then you also have to stop async when you close the application and you want to dispose all your objects. But then you implement delegates for processing. So inside the start async, you connect to the service bus, and then you create a processor client, and then you implement delegates for processing the messages and processing error messages. So if you look at my code, it's just simply with process message, I also just simply triggered the student registered notification. I have some handler down the line. Okay, let me just make sure that this is running. Oops, I'm missing an R. So you can see at the start, it's already connecting to my service bus. This is my demo service bus, so it's called Juicy Gossips. Ignore that. And then I'm just going to call my, my APIs. So this is the API for the students. So as soon as I register a student here, that will be executed. So I have my students registered. And the other thing is that, remember that I have two event handlers. One is to write to event grid, and the other one is to store that event. So if I want to get all the events about students, then I have that API student events. And you can see this is how an event looks like. So typically, you would have a schema for the event. You call the event schema. You would have your event type and schema version, which is also very important, because if you have consumers of your events, you might want to tell them how your event would look like. And if you want to change it, you might want to announce it and broadcast it that the schema is changing or in a new version and you need to upgrade. So that's why you have the schema version here. And then underneath, you have the actual data, which is the full state of the student. And when you change the state of the student, it will also append a new event in the store. And so what happens in the class, if I go to class and query that, I can see that there's already one student enrolled, FADE, which is the same as this person. And then if I add another one, let's say, so if I do that, you can see that this also, there's now a new enrolled students without calling the API, so they don't have any relationship with each other. It's just all integration within the events with a very simple code. So you can get this code in my GitHub. I'll share that to you later. So event-driven patterns. Let's get a little crazy and do something else. No one is crazy enough to join me. It's almost 4 o'clock. All right, what do we do with one of our projects? So now we have just been talking about native Azure services, but we can certainly do event-driven or be very creative with the way we implement event-driven, even though we're running things that don't use native cloud services or Azure services. We can do it on our own based on our use case. So we're also building a student, not just student, a school system, a larger school system for Denmark, and we thought about what if we implement event-driven end-to-end in full stack from client all the way to the database? Because so far we have just seen write events, commands. And then also it's not asynchronous all the way because at some point inside your handler, you have to request something against the database, and then that's not asynchronous. You have to wait for the database to reply that you have succeeded in persisting or updating your data. What we wanted to do is to make it asynchronous all the way to the data service, and we will just receive streams of results from all the layers and then push it all the way down to our clients, and that way we will make it very real time. So every time one browser loads data and updates it, all the other browsers that's looking at the same data will also receive it. You would say, okay, it's quite common. That's like, just using Signal R. But this one is, with Signal R, you still have like a little bit synchronous processing inside your API since it's calling the database, but we kind of want to experiment a bit. And we're also looking at the different services that would best do the job. So this is what we came up with. Maybe it's familiar for some of you. Maybe you have implemented it. Can you see it? Is it hard to see? Okay, let me just go through it. So at the bottom, you have all the clients. So you have, let's say for us, we have a web client and also a mobile client. Imagine that there's one student connecting to the same, as the same student, but different devices, right? So those are different sessions. And from our web client, we fire up a REST. We start with a REST request, but that's just to indicate that an event had happened. So we had to indicate, I want to write this. It's a request, but I'm not expecting a result. It's a command, please write this. And at the same time, our reads are also events. We fire up an event, say, I have subscribed to a list of students. So let's say from the client, I want, please create a student, or please register a student, and let me subscribe to the list of students at the same time. So we're not getting any results yet. We're just firing that up, and then we have two separate APIs, or we have a couple of APIs for doing writes, and we have one API that's doing query. And both of them are responsible for all these events that were fired by the client to maintain a state of that, so the subscribers. So we have in our query layer and our API layer sort of a cached or a state of all the subscribers. So we know how to get back to them later on. We know how to inform them once the processing has completed. And then, before we reach the database, we have a data service where we have a WebSocket connection. So within the WebSocket, we just say, I want to write this to the database, but I'm not going to wait for the reply. Just inform me when it's done, when your database operation is done. And that's the same with our query. I need the list of students, but I'm not going to wait for reply. Then, with this pattern, because it's totally asynchronous, they're all independent, you can pretty much be very flexible and scalable. So the data service talks to the database, and in this case, we actually we chose to use a database called XTDB. Anyone familiar? So XTDB is, it's based on Clojure. And it's a unbundled bitemporal database. It runs on a container, so we can run it on the cloud. And when I say bitemporal, then it's by default, inherently saves two types of data. And in event-driven application, time is very important attribute. And in this database, by default, it's very optimized to save two, or look, or query, or index two time dimensions. That's why it's bitemporal. Transaction time and valid time. You have a lot of temporal databases. DynamoDB is temporal. You save transaction time. You can go back in time. But for XCDB, you can go back in time in different dimensions. One is the transaction time when the event was committed, and the other one when the event is actually supposed to be valid. So for example, you register a student, and that student is registered today, but it's actually the registration is only valid next month. So the XDDB is very good at indexing that so that you can query what is really happening and when it really happened. Another thing with XDDB is it's unbundled. So to be able to execute that sort of, because it can also be very scalable, so it has clients or nodes, to be able to do that, it also uses the concept of event streams or immutable logs of database transactions. And to make it more powerful, you can use Kafka. So you can choose whatever storage there is that you can use to log transactions and to actually save the document, the attribute. So you have the document database, or the document storage and the transaction storage. And you can choose from the plethora of data platforms in cloud or hybrid what to use. So the core XDDB is just very lightweight. So we use that. It's Clojure-based. It's kind of smart. Sometimes I get confused what it's doing because I don't write Clojure. My colleagues do. So our data service is also running Clojure. It's in a container, so it still runs in the cloud. We can put that in Azure App Container Service. Is that right? Yeah. No, Azure Container Apps. See, I'm getting confused. Azure Container Apps so that we can make it scalable. But once the processing is done in the data service, it pushes back to the query that has all the again, the states of all the subscriptions or ongoing subscription, and it will only update, let's say you subscribe to a list of students. Then it will update that cache, the data service will, via the WebSockets, and the query service pushes down to all the clients. So if you have 10,000 students listening to get students, they will all be updated, and they don't have to refresh the page. Let's look a little bit, very quickly, on our test UI for that. So we have a UI that could illustrate what's happening with our data. So if I clear this and reconnect. So I have two browsers, two different sessions. And like I said, every single transactions you do, whether it's a read or write, is an event. So these are a list of our events. And each of these events have schema. So I can have an event called query by students by school. Students by school attribute. And if I say ngg here, so I get a list of all the data here. And that's just live, yeah? And then from the other browser, I can do the same. I can subscribe to students by school attribute, ngg. And you can see very fast that if I try to change one student here, let me say find user 02 here. So if I change this person's name to Marilag and update that, you can see this also updated in the same session using this paradigm. Everything is event-driven. All right. I have a few minutes left. So just go through. Again, when you start implementing event-driven or in your middle of it, there are so many things that we need to consider. Event schema, I have mentioned that. Having a kind of a central repository of all your events, if you're working in a big enterprise, would be helpful so that you can publish the catalogs. For example, the Azure. In Azure, you have a GitHub repository for all their schemas, for all the events that they fire from their infrastructure. And you can use Autorest to be able to auto-generate. Because they use OpenAPI, they can use Autorest to auto-generate some of this as, into code. Effectively once, exactly once, all this how many times, the idempotence of your applications or your API consumers. Ordering, if you need that, is very important in your design. How do you handle error in a distributed system? How do you trace all the events using a correlation ID for all the related events? And very important, security and privacy. Now that we're dealing with data that resides everywhere, data in transit all the time. So now we start talking about privacy. Can we actually delete data from an immutable database or event log? So things we need to think about. We learned a lot, different patterns. What can we use? that we can actually also be very creative and do full stack event-driven using open source. XDDB, by the way, is open source. But if we want to learn more, I'm going to share the links. I want to also recommend 2 books that I really like, Designing Data-Intensive Application by Martin Kleppmann and Fundamentals of Software Architecture by Mark Richards and Neil Ford. And I'm going to share my GitHub account. That second one there, the Designing Data-Intensive Application, made me cry. I didn't know that IT books can make me cry. Who does that? Thank you so much, NDC. Please reach out on Twitter at Marilag, and that's me at some hotel doing my star jump. Thank you.